2024 question 42. A simple distillation column separates a binary mixture of A and B. So this is a typical binary distillation column. The relative volatility of A with respect to B is 2. So normally alpha AB, let's call that simply as alpha is equal to 2, that is given. Okay. Um, so we know that by definition of alpha, this is the equation. We all know that, and of course this can be written in terms of xn and yn, and putting alpha is equal to 2. This is the relationship what we get. Okay. The state compositions of A in the vapor leaving the, let's call A is equal to 1, component 1, leaving the first, second and third phase in the rectifying section. So this is my rectifying section, are already given. So let's say this is my plate 1, this is my plate 2, and this is my plate 3. And we know here x1 and y1 would be in equilibrium in an ideal plate. Similarly, x2 and y2 would be in equilibrium. Similarly, x3 and y3 would be in equilibrium. And the line, similarly, x1 and y2 would be given by operating line. Similarly, x2 and y3 would be given by operating line. Okay. So how do you solve this problem? So y1, y2 and y3 are given. So from this equation here, we can calculate the value of x1, x2 and x3. So y1, y2 and y3 are given. We can calculate the value of x1, x2 and x3. Okay. Now for the rectifying operating line equation, we all know this is the equation here. For a constant reflux rate and the distillate composition, we can call this as K1 constant, and we can call this one as K2, this constant. So we can write this one as this equation right here. So putting n is equal to 0, n is equal to 1, and n is equal to 2, we get relationships right here. Okay. So let's take these two equations right here. So here we know the value of x1 and y2. We know the value of x1 and y2. Similarly, we know the value of x2 and y3. x2 and y3. We know these values. So if we just take these two equations, we can see that we have, since this is known, this is known, this is known, this is known. So there are two equations and two unknowns, K1 and K2. So we can easily calculate the value of K1 and K2, and we know that K1 is equal to this one, so we can calculate the value of R, and the value of R comes out to be this. So 2.689, B is the correct option.